Deep dive into sklearn's constant kernel for Gaussian processes. The constant kernel in scikit-learn's Gaussian process library is a simple yet powerful kernel, designed to capture the overall scale of the data. Let's dissect its workings, applications, and key aspects. 1. The essence of kernels in Gaussian processes. What are Gaussian processes? They are a powerful tool for non-parametric regression and probabilistic modeling. They model functions as random draws from a distribution, allowing them to capture complex relationships in data while accounting for uncertainty. Role of kernels. Kernels play a crucial role in Gaussian processes. They define the similarity between data points. A kernel function takes two input vectors and outputs a value that represents how similar these inputs are. This similarity is then used to construct the covariance matrix of the Gaussian process, which essentially dictates the shape and smoothness of the learned function. 2. Constant kernel. A simple, yet powerful baseline. Definition. The constant kernel in scikit-learn simply returns a constant value regardless of input data. This constant represents the overall scale of the data. It's represented as constant kernel constant value 1.0. Why is it useful? While seemingly trivial, the constant kernel serves multiple purposes. Baseline. It provides a simple baseline for comparison with other, more complex kernels. You can evaluate how much improvement a more sophisticated kernel brings over the constant baseline. Scaling. It helps to adjust the overall scale of the output of the Gaussian process. You can use it to match the variance of your target data. Combination with other kernels. Constant kernel often acts as a multiplier for other kernels. It can help scale the output of these kernels, making it easier to find optimal hyperparameters during model fitting. 3. Usage and example. Constructing a constant kernel. Python. From sklearn, Gaussian process, kernels. Import constant kernel. Kernel constant value 10.0. Adding it to a more complex kernel. Python. From sklearn, Gaussian process, kernels. Import RBF. Kernel constant 1.0 RBF length scale 1.0. This example combines constant kernel with the popular RBF radial basis function kernel, effectively scaling the output of the RBF kernel. 4. Hyperparameter optimization. Constant value. The primary hyperparameter of the constant kernel is constant value. It directly controls the overall scale of the output of the Gaussian process. This value is usually estimated during hyperparameter optimization. Optimization methods. Scikit-learn's Gaussian process regressor and Gaussian process classifier employ optimization techniques like gradient descent or LBFGS to find the optimal value of constant value that maximizes the likelihood of the observed data. 5. Common applications. Scaling output. When you know the data should have a specific scale, e.g., a standard deviation of 1.0. Constant kernel is often used to adjust the output of other kernels to match that scale. Simple baseline. It can serve as a starting point for evaluating the performance of other, more sophisticated kernels. Combination with other kernels. Constant kernel is commonly used to multiply other kernels, allowing for fine-grained control over the overall scaling and variance of the Gaussian process. 6. Limitations and considerations. Simplicity. While powerful, constant kernel is inherently simple. It cannot capture complex relationships or varying levels of smoothness in the data. Choosing the right kernel. The choice of a kernel significantly impacts the performance of a Gaussian process. Constant kernel should not be used in isolation, but rather in combination with other kernels or as a baseline for comparison. Hyperparameter optimization. It's crucial to optimize the constant value hyperparameter to ensure the model fits the data well. Conclusion. ConstantKernel is a versatile tool in the Gaussian process toolbox. Although simple, it plays a vital role in scaling outputs, establishing a baseline for comparison, and enhancing the performance of other kernels. By understanding its capabilities and limitations, you can effectively leverage ConstantKernel to build robust and accurate Gaussian process models.